You know, every skyscraper, every smartphone, even the satellites orbiting our planet, they all started as just an idea. So how do we get from a thought to a thing? Well, that's what we're digging into today. We're unlocking the engineer's toolkit, all the essential instruments, from ancient hammers to cutting-edge code that literally build our world.
And the answer isn't just one single tool, right? It's his whole ecosystem of invention. It's a story that's all about muscle, electricity, and even pure data. So let's jump right in.
All right, here's the game plan. First, we're going to figure out what an engineering tool even is. Then, we'll dive into the classic showdown, hand tools versus power tools. From there, we'll peek inside the core toolbox, check out some really specialized gear and software, and wrap things up with the super important art of precision.
Okay, so first things first. Before we can appreciate the sheer variety out there, we need a solid foundation. So what exactly is an engineering tool? I bet the definition is way broader than you're imagining.
And there you have it. The big takeaway here, it's not just about physical stuff you can hold. The fact that software is included is absolutely key. I mean, that's a massive shift, right? It means some of the most powerful tools an engineer has aren't made of steel at all. They're made of code.
So for now, let's stick with the physical tools. It really all boils down to one simple question. Where's the energy coming from? And that question splits the entire toolbox into two big fundamental categories: hand tools and power tools. So on one side, you've got pure human force, tools powered by your own muscle. But on the other side, you've got tools that harness electricity, fuel, even compressed air. And look, the goal of a power tool isn't just about making the job easier. It's about hitting a level of speed and force that, let's be honest, a human just can't physically match on their own.
Okay, so keeping that difference in mind, let's crack open a typical toolbox. What are the absolute essentials you'd expect to find inside? I'm telling you, the variety is just staggering.
We'll kick things off with the fundamentals, the hand tools. And you know, a lot of these have been around for literally centuries. You've got your tools for making sure everything is perfectly straight and level, like a spirit level. Then you've got tools for shaping, like a file, that just shaves away tiny bits of metal with incredible precision. And of course, the absolute classics for gripping and striking, pliers, and the good old hammer. Seriously, every single one of these is a masterclass in simple, effective design.
And next up, we've got the tools that literally hold our world together. I mean, we all know screwdrivers and wrenches, right? But check out the tap and die set. Now this is where it gets really cool. This little kit doesn't just tighten screws, it creates the threads for them. Think about that. With this, an engineer can make a totally custom bolt or fix a stripped screw hole from scratch. It's just the perfect example of a simple-looking tool that has incredible power.
You know, this brings up a really core idea in engineering. It's so easy to think that more power is always better, but that's just a myth. For jobs that need delicate control, that real tactile feedback, like, feeling the tension in a screw as you tighten it, a hand tool is often way better. A great engineer knows it's not about having the strongest tool in the box, it's about having the right tool for the job.
And then you look at the power tools, and the range is just as mind-blowing. You can go from the raw brute force of an angle grinder that literally tears through solid steel, all the way down to the delicate precision of a soldering iron that's just melting a tiny drop of metal onto a circuit board. It's the same basic principle, using electricity, but applied to completely different worlds of scale and force. It's amazing.
But what happens when your standard toolbox just won't cut it? Well, that's when you enter the world of highly specialized tools, and we're talking both physical and digital.
Just think about electrical engineering for a second. In that field, the wrong tool isn't just inefficient, it can be deadly. You obviously can't use a standard pair of metal pliers on a live circuit. So in this world, the tools are designed with one thing in mind above all else: safety. Keeping a safe barrier between the engineer and a potentially lethal shock.
And this number right here is the key: 1,000 volts. To put that in perspective for you, your standard wall outlet at home is probably around 120 volts. So yeah, this rating isn't a suggestion. It is a rigorously tested guarantee that this tool can save your life. It basically transforms a simple screwdriver into a critical piece of safety equipment. So this whole specialized kit is all about two things: safety and diagnosis. You've got the insulated tools for physical protection, sure, but then you have diagnostic tools, like a voltage tester. Its only job is to answer one supercritical question: is this thing live, before you even think about touching it? Every single item here is designed to help you manage that invisible danger of electricity.
Okay,
Now we're going to take a huge leap from the physical to the digital. Think of it this way. CAD software is like your infinite digital blueprint. It's where an engineer can design and test a part in a virtual space. Then you have CAM software. That's like the translator. It takes that digital blueprint and tells a real-world machine exactly how to cut, drill, or shape the material. And 3D printing software? Well, that's the magic button, the instant creation engine that turns that digital model into a physical object, right there in front of you.
And finally, let's talk about what might be the unsung hero of the entire engineering world: precision measurement. Because at the end of the day, if you can't measure it accurately, you just can't build it correctly, period.
And at the very heart of all this precision is the gauge. Simply put, a gauge is any device you use to check a dimension with absolute certainty. This is the difference between professional engineering and just guesswork. It's what makes sure every single part fits and works exactly the way it was designed to.
And the tools they use for this are just astounding. I mean, a standard ruler might get you to a millimeter. A vernier caliper, that'll get you to a 1/10 of a millimeter. But a micrometer? Wow, that can measure 1/100th of a millimeter. We're talking thinner than a human hair. And then you have something wild like a feeler gauge, which isn't even for measuring an object itself, but for measuring the tiny critical gap between two objects. This is truly the world of microscopic precision.
So, we've gone on this incredible journey, right? From tools that just amplify our muscle, to tools that channel electricity, all the way to tools made of pure information that let us measure the invisible. Every single step has been a huge leap in what's possible for us to build. And that leads to one final, fascinating question. As AI starts to design things and robots start to build them, what on earth is an engineer's toolkit even going to look like 50 years from now?